If you saw my last video, you saw that I covered ferrous metal alloys which have iron in it, but here we're going to cover non-ferrous metal alloys which have no iron, and we really only use these when we just can't use any of the cast iron or steel subtypes, because these are more expensive. So we're going to have a look at aluminium, copper, titanium and refractory metals. So copper and its alloys. Unalloyed copper is so soft and ductile that it is difficult to machine, but it has an almost unlimited capacity to be cold worked. It is highly resistant to corrosion. It's not really strengthened by heat. One of its alloys is brass, which is made of zinc and copper, and bronze is made of copper and tin, aluminium, silicon or nickel. Bronze has got quite a bit in it. Bronze is stronger and more corrosion resistant than brass. Copper has excellent mechanical properties, mainly that it has It has excellent electrical and thermal conductivities, and it can be casted into complex shapes, which is very helpful. So aluminium and its alloys. It has a relatively low density compared to iron. It has high electrical and thermal conductivities. It does have a great specific strength, so it's got a high strength to weight ratio. It is corrosion resistant because it's protected by self-oxide scale, and the electrical conductivity when lightweight is important, such as overhead power lines, is great for aluminium. It's not that toxic, so it's great for food packaging. Titanium. This has a very high specific strength, tensile strength up to 1400 MPa. It's highly corrosion resistant. It's also protected by self-oxide scale. It's immune to air, marine and many industrial environments, and it is highly biocompatible. So it is great for industrial corrosion applications. So refractory metals. These have an extremely high melting point, over 2400 degrees Celsius. They've got a relatively high density. They are chemically inert, they're very hard, and thus they are extremely resistant to heat and wet, which is great. So they're usually used in filaments, thermocouples, and furnace heat shielding, as well as nuclear reactor components. So yeah, that is pretty much it. It's a relatively short one, not as extensive as the ferrous ones, but this field is quite interesting to study into. Thanks for watching.